Imagine this. For months, Voyager 1, a spacecraft older than the Internet itself, had gone completely silent. 15 billion miles from Earth. No signal, no data, just silence. A silence so deep, so absolute, it felt like the universe itself had drawn a curtain. Scientists feared the worst. Had our furthest explorer finally died in the dark? And then, just as hope was flickering out, a whisper returned. But it wasn't a normal update. It wasn't a system reboot or a status check. What Voyager 1 sent back cracked open the illusion we had always clung to. That the void beyond the sun was just that, a void. Because what Voyager revealed wasn't emptiness. It was structure, movement, pressure, boundaries. It had reached the other side. But what it found there is nothing like what anyone expected. Keep watching because the truth Voyager is uncovering about the interstellar medium is more astonishing and more unsettling than fiction ever dared to suggest. When Voyager 1 crossed the heliopause in 2012, it became the first human-made object to truly leave the sun's protective bubble. Many believed it would drift into silence, passing into a dark, empty stillness. But in April 2024, after months of garbled transmissions, Voyager came back online. And what it started sending shook the foundation of astrophysics. Out there beyond the heliopause, space isn't quiet. It's humming. A low-frequency oscillation, steady and rhythmic, fills the void like the pulse of a living thing. Voyager's plasma wave instrument detected a kind of ambient energy whispering through the interstellar medium. But it wasn't just the hum. The spacecraft also measured density spikes, bursts of pressure like shock waves left behind by ancient supernovae. It's as if Voyager was passing through layers of memory. Zones in space shaped by stellar deaths that happened thousands, maybe millions of years ago. Interstellar space isn't an empty corridor. It's a swirling ocean of invisible currents and echoes. And Voyager as our tiny sailboat, navigating blind through weather we never even knew existed. As Voyager pushed deeper, its instruments began painting an image no telescope ever could. A three-dimensional structure hidden in the dark. Its magnetometer picked up a sharp misalignment in the galactic magnetic field, twisting violently against the sun's field, like two tectonic plates grinding together. This wasn't random. It was patterned, structured. The magnetic turbulence Voyager recorded hinted at something more. That the galaxy itself might have a magnetic skeleton, vast filaments of force shaping where matter flows and where it doesn't. Some regions deflect cosmic rays. Others funnel them in streams like radiation rivers in the dark. Voyager found it had crossed one such threshold, a sharp spike in high-energy particles accelerated by distant black holes in supernovae, slamming into the probe at near light speed. These weren't gradual changes. They were abrupt, sharp, like stepping from one biome into another. We used to think the sun's heliosphere was a soft gradient fading into space. But Voyager proved otherwise. It's not a shoreline. It's a cliff. And beyond it, the rules change. In late 2023, it looked like the Voyager mission was over. The signals were garbled. The data unreadable. The spacecraft systems designed in the 1970s seemed to be failing. But NASA engineers didn't give up. They traced the issue to a corrupted memory chip likely struck by a cosmic ray. Ironically, one of the same phenomena Voyager was studying. And from 15 billion miles away, they did the unthinkable. They rerouted Voyager's software into backup memory. Hardware older than most of the people fixing it using commands that took 22 hours round trip. It was like performing brain surgery with 1970s tools through a time machine. But it worked. In April 2024, Voyager came back to life. First its engineering data, then its magnetometer, then plasma and cosmic ray detectors. One by one, the instruments reawakened. And with every reactivation, the spacecraft gave us something new. Something no simulation, no telescope, no AI could ever give us. First-hand readings from the inky black between stars. Voyager wasn't just restored. It was reborn. And with it, so was our window into the deepest truths of the galaxy. What Voyager is sending now is more than just numbers. It's a blueprint, a living map of interstellar space. Scientists are using its data to chart the first ever galactic GPS, not for navigation through planets, but through radiation zones, magnetic boundaries, and invisible cloudlets. Voyager has passed through at least 2 interstellar clouds, regions of denser gas and plasma that ripple like invisible fog banks. And in each one, it recorded different conditions, different temperatures, and different magnetic alignments, like crossing continents with invisible borders. One day, these maps might guide future astronauts through safe corridors, using natural magnetic shielding to dodge deadly cosmic rays. But even more profound is what these structures might mean. Some astrophysicists believe Voyager's readings could help explain how stars are born. The way these filaments and pressure zones funnel material may be seeding the next generation of suns. Voyager isn't just a probe. It's a cartographer, a scout. And the path it's tracing may be the key to unlocking the very anatomy of the galaxy itself. We used to believe interstellar space was uniform, a neutral expanse of particles randomly dispersed across millions of light-years. But Voyager 1 is revealing something vastly different, something dynamic. Think of it not as a void, but as an atmosphere, one with pressure zones, eddies, and even storms. As it pushes farther into the galaxy, the spacecraft has encountered what scientists now call interstellar weather. Using its plasma wave instruments, Voyager has recorded sudden changes in temperature, density, and energy levels. It's as though it's flying through pockets of invisible mist, each with its own climate. These aren't chaotic fluctuations. They are structured, layered, defined. Voyager has detected distinct boundaries between interstellar cloudlets, small dense concentrations of gas and plasma likely shaped by long-dead stars. Some contain higher magnetic pressure, others more radiation, and some exhibit low-frequency hums like the echo of distant thunder. In Earth's terms, this would be like discovering ocean currents in what we thought was desert. And as Voyager keeps sailing forward, it confirms that the galaxy is not a static map. It's breathing, shifting, and alive. Voyager's voyage through the galactic outskirts has brought it face to face with what may be one of the galaxy's most mysterious features, the local bubble. This is not science fiction. It's an enormous invisible cavity in space, spanning hundreds of light years, likely carved out by a series of supernovae millions of years ago. Voyager's readings suggest it's now mapping the bubble's outer edges, crossing zones where density changes abruptly and magnetic patterns distort like funhouse mirrors. These boundaries aren't just scientific curiosities. They are scars, remnants of cosmic violence written in the plasma and dust that now cradles our solar system. Some researchers believe that within these zones, Voyager is catching the echo of those ancient explosions, not just metaphorically, but literally in the form of charged particles and magnetic shock waves that have taken thousands of years to reach this point. These are the bones of stellar death, and they shape the space around us. Voyager is moving through a graveyard of stars, and with each reading, it's decoding the galaxy's forgotten past. What it's mapping now could change how we trace the lineage of everything from the formation of stars to the path of our solar system itself. Among the most eerie revelations of Voyager's recent data is the realization that silence does not exist out there. While our telescopes can't see anything in these regions, Voyager hears them. Its plasma wave sensors have picked up continuous low-frequency sounds, steady oscillations that never cease. Some of these frequencies seem to vary slightly as the spacecraft moves, as if it's entering new zones of vibration. These aren't radio emissions, nor are they cosmic background noise. They're more like the resonance of the interstellar medium itself, a kind of symphony being played across magnetic fields and plasma clouds. It's a form of cosmic weather perhaps, or a galactic heartbeat. Some scientists now speculate that this hum could be a signature of how the galaxy organizes itself, a byproduct of gravitational interactions or magnetic turbulence. But others are more cautious. They wonder if this persistent oscillation might be something we don't yet have the language to describe, something akin to natural resonance or worse, something unnatural altogether. Whatever it is, Voyager is not just detecting it. It's moving through it, part of the song now, and we back on Earth are hearing it for the first time. So the next time you look up at the night sky and see nothing but stars, remember 15 billion miles away, a golden-plated messenger is still drifting, still listening, still mapping the unseen bones of the galaxy. And maybe, just maybe, it's reminding us that the real frontier was never out there. It was always our need to understand. If you've made it this far, then you're not just curious. You're one of the few who truly listens when the universe whispers. So, tell us in the comments, what do you think Voyager 1 will find next out there? Beyond the maps, beyond the models, beyond everything we thought we knew. Hit that subscribe button and turn on notifications because this isn't just another space story. It's the beginning of a much deeper one. And trust me, you'll want to be here when the next signal arrives.